U.S. Army installs proof gun system at Yuma to speed artillery round testing. Yuma Test Center has installed and fired a proof gun system for the first time, giving the U.S. Army a dedicated artillery testing platform that can swap gun tubes in and out without ever needing a complete howitzer on the range. The proof gun system was developed by the U.S. Army Combat Capabilities Development Command Armaments Center and acquired by YTC to support production testing of 155mm artillery munitions. According to the Army's account of the installation, the funding for the system comes directly from the Army's initiative to ramp up overall production capacity for 155mm rounds. A second PGS is scheduled to arrive at Yuma in May. The idea was to build a system that would allow them to put a number of different tubes in, said Quinton Sorensen, the test officer with the Munitions and Weapons Division, who oversaw the installation. There are no electronics, it's hydraulic or mechanical. It was specifically designed to sit out in the desert. They are hoping for a 30 to 50-year lifespan, Sorensen said. A testing platform designed to last half a century and function without electronics in the extreme heat of the Yuma Desert is a piece of infrastructure built for reliability over a long production testing horizon, not for a short-term program need. Installing the PGS required constructing a reaction mass capable of absorbing the forces generated by firing a large-caliber artillery tube repeatedly. A U.S. Army Corps of Engineers contractor built the foundation to YTC standards, going approximately 7 feet deep with rebar grids and a fabricated cage housing removable mounting rods designed to secure the ground engagement system adapter plate. The concrete is about 7 feet deep and contains rebar grids and a fabricated cage that houses the removable mounting rods designed to secure the ground engagement system adapter plate, explained Jared Ford, the chief of the Indirect Fire Modernization and Mines branch. Getting the PGS onto that reaction mass was a full day's work. Crews had to clean and prepare the adapter plate and place the saddle or lower portion, then mount the gun mount or upper portion on top of that, and spend the rest of the week confirming that everything was locked down. The mounting bolts were torqued to 3,100 foot-pounds using a specialized large pneumatic wrench. Carpenters then built a wooden deck around the system to provide close access to the loading side. We fired at 4 QEs just to make sure everything was good as we elevated up and down. Most were done at Zone 5 to introduce maximum shock, and everything went well. He said Zone 5 represents a hyperpellant charge that generates significant recoil forces, and firing at multiple quadrant elevations across that charge confirmed that the mounting system holds its position and performs correctly across the range of angles the PGS will be asked to accommodate during testing. The operational rationale for the PGS becomes clear when you compare it to how artillery testing currently works at Yuma and similar test facilities. Testing a complete howitzer requires towing in an M777A2 or M199 towed howitzer, or driving in an M109A6 self-propelled system, then maintaining that entire weapon system in operational condition for the duration of the test program. We have to tow in a towed howitzer like an M777A2 or an M199, or you have to drive in an M109A6. You have to bring in the whole system, and then you have to have it ready and running to conduct your test. Sorensen explained every element of that process that doesn't directly involve the gun tube and the ammunition being tested is overhead that adds time, cost, and mechanical complexity without contributing to the test objective. The PGS eliminates everything except the tube itself. You just swap the tubes in and out as you need, and then you're not trying to constantly maintain a chassis because you have this one system that will handle everything. Sorensen said it minimizes setup costs and it minimizes the mechanical effort of keeping the whole system functioning when all we really need is the tube, he added. Reaching 100,000 155mm rounds per month requires not just manufacturing capacity, but testing capacity to validate that the rounds being produced meet specification. Every production lot of artillery ammunition requires proof testing, firing rounds from a standardized gun tube under controlled conditions to confirm performance, and doing that at scale means the test infrastructure has to keep pace with the production line. A PGS that can handle multiple tube types from a permanent installation without the overhead of maintaining complete howitzer systems is the test infrastructure answer to a production ramp that is being driven by the lessons of Ukraine, where 155mm ammunition consumption rates have repeatedly exceeded Western stockpile assumptions.